Okay, good morning everyone. My name is Frederick Brock and I'm going to be taking you through the webinar this morning. We're going to be covering the PubNub iOS version 4 SDK. We have quite a bit of material to go through, so I'm going to try to keep up a pretty good pace. We have some code to share with you. There's some GitHub repositories that are currently set to private, and I'm working on getting those switched over to public. So for the webinar, you probably won't be able to download the code, but after the webinar, it should be set up to public, and you can go out and download the demo app and some other artifacts that we have available for you to pick up on the new PubNub iOS version 4 SDK. Initializing PubNub is fairly straightforward. Again, we want to import the header file, PubNub header, and then we're going to have one PNObjectEventListener to respond to events, and then we're going to want to declare a property somewhere to store a reference to PubNub. Okay, very straightforward on that one. Construct an instance of the PubNub object. So in this slide here, we're actually doing it in your did finish launching with options, which is right out of your app delegate. We're instantiating an instance of PN configuration. So here we do a PN configuration with published keys. These are the keys that you would get in the customer portal or the customer dashboard. So once you have an instance of the PN configuration, you can alter or leverage some of the attributes off of PN configuration to control how the SDK behaves under certain conditions. In this particular case, I'm altering the presence heartbeat interval and the heartbeat value. So the heartbeat interval is how often the client is going to send a heartbeat to the server. The heartbeat value is how long the server is going to wait to hear from that client. And then there's some other options here, such as restore subscription, which allows you to weather temporary outages, network outages, and then specifying a UUID, which is how we identify an instance of PubNub on the PubNub side. So you're definitely going to want to use a UUID when it comes to using presence. Everybody's identified by their UUID. Usually, this is going to be your user profile ID. Okay. Once you have that PN configuration option or object instantiated and configured the way you like it, the next thing you're going to want to do, oh boy. Next thing you're going to want to do is instantiate, sorry about the slide hiccup there, instantiate the client PubNub instance using the client with configuration. I pass in an instance of the configuration and return yes. And that will instantiate your instance of PubNub, and now you're ready to start subscribing to channels. And just so for those of you that are unfamiliar with PubNub, channels are a destination and a point of consumption for messages. That's how we know where to send a message when you publish a message, and when you subscribe, how we know where to pull messages from is a channel. And they're dynamic. They're just based on names, and you can create as many as you like there. So. All right. So on the code side, for me, for Chatterbox service, I'm doing all that as a service, and I have a connect as user method here, or selector. And within that method, I'm actually enabling logging. This is something that's not in the slides, but there is a PN log there, and you want to set that to enabled. It will give you good diagnostic information as you use the SDK. I have a profile that's being passed in, and that's a Chatterbox user profile, and it just identifies that particular user. When you are able to download the code, you can go and do some analysis of that. I'm instantiating my instance of my PN configuration. I don't retain a reference to my PN configuration because I don't need it, but sometimes that might be beneficial for you. I assign my UUID. Very, very important. Make sure you assign your UUID. If you don't, one's going to be generated for you. But for most typical use cases, you're going to integrate with a third-party data store or an internal data store, and you're going to want to use your profile ID as the UUID. so that you're identified by that and it links up with your external systems. I'm doing some configuration here on Presence Heartbeat. And I'm instantiating my instance of PubNub. I'm adding a listener. And we'll get to this in just a minute. And then I'm subscribing to some channels, and we're going to get to that in just a minute. Okay, and then I'm setting a flag here in my Chatterbox service, initialized equals true. All right, subscribing to a channel. So I kind of covered this a little bit, but I would just want to cover it a little bit more in depth. A channel is just a name, but it identifies a point of consumption for messages and a destination for messages. It's how we know where to route messages to and how we know where to pull messages from. Okay, so you hear that channel concept or term being used throughout the material. It's just a name. Okay. They only exist when an app publishes a message to them or somebody subscribes to them. There's nothing on the server that you need to do to create a channel. You just simply create a name and subscribe to that channel. All right. So subscribing to a channel, very easy. Once we have our PubNub instance initialized, the next thing we're going to want to do is add a listener. So in PubNub land or iOS SDK, most of your stream events are handled by a listener interface. That's a very, very simple interface we're getting ready to cover. It's called PNObjectEventListener. And the very first thing you're going to want to do is add one or more listeners to your instance of PubNub. If you don't do this, you're not going to receive any events when you've subscribed to a channel or published a message. So you want to do this prior to subscribing or attempting to publish. Okay. The PNObjectEventListener interface is made up of 3 methods. For the most part, if you wanted to write a simple chat app, you can almost get by implementing these 3 methods alone. It's very, very straightforward, very simple. They all accept one argument as the argument being passed in, and it's usually in the event or in the form of a result or a status. So there's 3 methods. didReceive message, that's going to happen when you receive a message on a channel. didReceive status, that's going to happen when significant events occur, such as connecting or reconnecting to PubNub. And then there's presence events, which we'll cover a little bit later down the road, but it's didReceive presence event, and again, it's a PN present event result. Okay, PNObjectEventListener is the interface that you need to implement. You can have one or more of these. So if you have an application with several UI view controllers, each view controller can be a listener. If you take a different approach, such as I did with a kind of a service manager facade, your facade could be a listener, or it can be both. It's entirely up to you. So you can have one or more of these, and I highly suggest you have as many as necessary to implement your use case and ensure that each implementation of this listener interface has, a single responsibility or a limited set of responsibility and scope. In other words, don't implement one super ooper duper PNObjectEventListener and have everything that your app needs to do in that one listener. Split it up. If you have a chat window that's going to display chat messages, maybe have one for that. Have one that publishes. Maybe have one that listens for presence events. Have one that listens for connection and disconnection events. Try to keep the responsibility of these listeners limited in scope so that your code's easy to test and easy to change. didReceive message. didReceive message is the method or the selector that will be invoked when you receive a message. It's passed in a PN message result, and that hierarchy of that PN message result is below. So we have at the top level PN result that's being inherited, or PN message result is inheriting what's in PN result, and then you have PN message data, which gives you the subscriber data or the actual data for the message. Okay. PN subscriber data contains channel and time token. So when you subscribe and you implement your didReceive message, you'll have a subscribe channel and an actual channel. The actual channel is the one that initiated the event. The subscribe channel might also be a channel group if you're dealing with channel groups or stream controllers. We won't be looking at stream controllers today, but it's there and it's the same interface as PubSub. So what you pick up on here in the webinar is applicable to stream controller as well. Last but not least, there's a time token associated with subscriber data that can be used to either format and display when a message was received to the user, or it could be used to go back into history and pull messages that were published prior to this message that you're actually receiving. Okay. Here's an implementation of a didReceive message. Okay. So here's didReceive message, and I have my implementation. And in my case, this is the Chatterbox implementation. I'm just iterating through a collection of listeners that are Chatterbox specific and invoking the message received. And then somewhere in my view controller, I have a message received implementation that takes a Chatterbox message and just adds it to an array, which is going to be pulled on from a UI table data source. Okay, very, very straightforward. Again, it's just one argument, one method. You're passed in a reference to the client, so if you need to make other PubNub calls, you can do that here. It's going to be a PN message result. I'm grabbing that message, creating a domain-specific object called a Chatterbox message, and then I have a domain-specific interface called Chat Room Listener that I iterate through, and I just invoke the message received method. Okay. All right. Used to notify your listener didReceive status. So didReceive status is a method off of the PNObjectEventListener that is invoked when connection and disconnections or non-stream events occur. You definitely want to implement that method and ensure that you're handling the connected, unconnected, and reconnected category status messages. And here's a very, very small implementation of that. And I'm saying if the status is, if it's not an error, then what's the or what category of status event am I actually receiving? And then I can do what I need to do as part of my application. So going back into the code here. Here's an implementation of didReceive status. And this didReceive status, I check to see if I'm connected. If I am connected, meaning I've subscribed or I've instantiated the instance of PubNub, then I can do a set state, which we'll get to here in a little while. Otherwise, if I'm reconnecting, I can actually do a history for channel. Okay, so this is the way that you would want to use didReceive status. Okay. All right. And finally, last but not least, so we went over the PNObjectEventListener, and the reason why we had to kind of segue into that and go over those three methods is in order to receive messages from channels that you're subscribed to, you need to have one of these listeners implement it. You need to register that with the SDK, which I'm doing here. And then the last thing that you're going to want to do is just call subscribe to channels, and it actually says groups, so I need to fix that. It should just be subscribed to channel. But you'll want to subscribe to channels. And subscribe to channels accepts an array of channel names and then allows you to determine whether or not you want to receive presence events. In our case, we will. And we'll get to that here in just a tad bit. But once you have this and you've added your listener, and you have your listener implementation, any message that's published to the CB-global channel will result in your didReceive message being invoked and the code being executed. Okay. Okay. Moving right along here, publishing messages to a channel. So publishing messages to a channel is a very straightforward process. Again, it's one method that has a variety of overrides for various conditions, but for the most part, it's a straightforward process. This is considered kind of a non-stream method in the SDK, so it actually accepts a block when you're publishing a message to indicate when a message has actually been published successfully or an error has occurred. The publish payload is pretty straightforward. When you publish a message, you're not going to get the message back. As the publisher of the message, you're going to get a success flag, a status message, and a time token. These are all relevant for you because in the event that there's an error, obviously you'd want to handle the error, but the time token is useful for you as well. If you have to go back in history, you could use that time token to denote where in history you want to go back to so that you can pull messages that were published after or before that. Okay, a successful callback or successful publish will result in a payload similar to this, which would be a 1, which means success sent with some time tokens, and a failed message will result in a payload similar to what you see here, which is 0, some reason to indicate why the message wasn't published, as well as a time token. And as you can see, in this particular case, the message was too large. We do have a constraint of having messages under or up to 32 kilobytes. Okay. All right, what does it look like to publish? So here's a very small implementation of publish method, and I want to just point out a small caveat. I am grabbing my PubNub client from my app delegate, and this is probably not a good idea. If you're writing a production quality app, you probably want to pass an instance of PubNub into the view controller so that you don't have to do odd things such as this, and that's actually my fault. So we've got a button here, app delegate, UI application, shared application, app delegate. I grab my instance of PubNub. I'm grabbing a text back from a text box. I'm putting together a JSON packet, and then I'm publishing that message out. I pass in the message, the channel that I want to send it to, whether or not I want to compress that message, and then it also accepts a completion block. So if the event doesn't result in a method on PNObjectEventListener being invoked, then that method will probably accept a completion block. Those are the two ways to interact with the SDK. Okay. These are asynchronous calls as well. I just want to mention that the SDK is asynchronous, and when you make these calls, you can't simply check a result or a return value from the call. You definitely want to implement the completion block and use those as the indicator that the function that you've asked the SDK to do, be it publish or grab history, has actually been completed. Okay. So here's a callback block, or the publish with a callback block implemented. You want to check your status object and see if it's in an error. If it is, notify the user that something's happened. Otherwise, you might want to grab the time token of the message, or that was assigned to the message when it was published. Okay. Again, very simple. Even the blocks accept one argument, and in this particular case, it's a publish status, and typically they have status.data and some attribute, or status.asr. Okay, very straightforward. This is a didReceive status, and this actually is not the case. I'm going to skip over that. Listening for present state changes. Okay, so we're going to move right along. So we've set up our project. We've initialized PubNub by instantiating an instance of PubNub, adding our PNObjectEventListener. We've then subscribed to a channel, and so we can receive messages that was subscribed to channels, and indicating whether or not you want to listen for presence events. And then we've looked at publish as well. So very, very straightforward. All the methods are single argument. They're typically either results or status. It is asynchronous, so you want to use completion blocks where necessary. and use that as your indicator of a function actually being completed. So now we can subscribe and publish messages. The next thing you're going to want to do is listen for presence and state changes. Okay. All right. So presence and state. So when you create a channel on the PubNub side, you're actually creating two channels. If I have a channel called test, then on the PubNub end, I will have two channels, test and then test dash PNPres. If you look at the bottom of this slide here, I have a presence channel CB-global-PNPres. So when I subscribe to CB Global, there's actually two channels available. Well, that second channel is used to propagate presence information and state changes back to your client. And as you saw with the subscribe to channels, if you indicate that you want to receive presence events, then presence events will be sent over this PNPres channel. I bring this up because you can actually subscribe just to the presence channel. Let me go back there. You can subscribe just to the presence channel if you like, and only listen for presence events. And there are some use cases where that's beneficial. Maybe you want to subscribe to a global chat room and then just subscribe to the presence and on the server side so that you can do graphs and charts, whatever the case may be. But that is possible, and that is feasible for you to do. Okay. Presence and state. There's actually just 4 events for presence and state. Okay, when you subscribe to the presence channel, the method of the PNObjectEventListener didReceive presence event will be invoked, and it's going to be invoked with one of these 4 events. First one is going to be a join event, and that's when a new subscriber joins or subscribes to the channel. A leave event, and this happens when a user or when you call unsubscribe on a channel. So when somebody leaves a room. And I want to make sure, just to point out, if you subscribe to channels and you don't leave the channel, then a user is going to be in limbo, and then eventually they'll time out. So in the case of a chat app or even an IoT app, whatever the case may be, a lot of times I've seen people subscribe to a channel, and then they're wondering why they're not getting leave events when they close the browser window or when they close the app, and that's because they didn't explicitly unsubscribe. If you don't explicitly unsubscribe, what's going to happen is you're going to be on that channel for a period of time until you time out, and then you'll get a timeout event. But that could be several minutes later, depending on how you have the SDK configured. Okay, so you're going to get a join when folks join the channel. You'll get a leave only when unsubscribe is called. And then you may, if unsubscribe is not called, somebody has a network outage or they've walked away from the computer, eventually you'll get a timeout. Whenever the client doesn't send the server a heartbeat within that heartbeat period, then the server will eventually issue a timeout. Okay. And then the last event that's kind of a odd duck off to the side is state change. We allow you to send state, which is just application defined data. Maybe if you're doing a chat app, it might be an emoticon, it might be a mood or location, whatever you can represent in JSON easily, you can use to propagate state for a given user on a given channel. And the way that that is sent to other users on a channel is through a state change event. And that's when the user actually calls state, and we'll look at that in just a minute. The payloads behind the scenes, and the SDK wraps this up quite nicely, but the payloads behind the scenes for these particular events look similar to what I have here, which we have a join, we have an action, timestamp, UUID, occupancy, and then this is the state value that's being sent with that particular join event. Okay, so again, action is going to denote the particular action type or presence event type. The timestamp will give you indication of when that event occurred. The UUID is the instance that caused the event to occur, and then we'll have occupancy. In this particular case, it's 2 and state. Okay, all of the presence events have an action attribute associated with them. That's the one that you want to interrogate to determine what kind of event you're dealing with. Okay. State data is sent on a join. It may or may not be sent depending on which platform you're on. If you've joined a room or joined a channel and sent state, then you close your app and you go back in, you send the same state values. Again, the second join will not have the state information. Okay, and the workaround for that is don't count on having state data in your join events. As opposed to doing that, when you get a join event, use the UUID and ask the server for the state. So subscribing to state and presence events is subscribing to presence events, subscribe to channels. And again, I have a mistake here. It should just be subscribe to channels, not channel groups. My apologies. Apologies. I was doing the slides and I must have auto-clicked on this. Here I'm subscribing to a channel called CB Global with presence yes. And that will tell PubNub that we're interested in receiving presence events on the CB Global channel. Again, presence events are per channel per UUID. So if I had a chat app that had 2 rooms in it and I was subscribed to both of those rooms as user ID F Brock, then each room I could have different state or a different presence. Okay. All right. When a present event occurs, listeners registered with the SDK will be notified. Again, going back to PNObjectEventListener, it's just going to be the didReceive presence event selector. Okay. And here I have a didReceive presence event implementation. I'm checking the event that's coming in. I'm seeing if that presence event is joined, so presence event maps to action on the payload. If it is, then I'm checking to see if it's on the channel that I'm interested in. You may or may not need to do this depending on how you've implemented your listeners, but I'm checking to see which channel actually caused that event. Then I'm grabbing the UUID, and in this particular case, I'm going back out and I'm saying state for that UUID. So what I'm trying to accomplish here is I'm saying whenever somebody joins my channel, I want to turn around and go ask the server for their most recent state information. And this is the way you typically want to do this because you don't know if the join payload is going to contain a state. You can always check to see if the state is present, and if not, go out and ask for it. But I usually do it this way. State for UUID is the method that you're using to ask for state. It accepts a UUID, a channel, and then as with all non-stream events, it has a completion block associated with it, and it has 2 arguments, PN channel client state and an error status. And you would just process that data as it came back. Okay. Setting the state can be done at any time. So if you had something similar to somebody's going to change their mood from happy to mad and sad and glad, then you can do that. And here I'm checking status. If I've connected, this would be in my didReceive status. Then I'm going to go ahead and populate some data, and I'm going to call set state. Okay. Other methods that are available to you with presence and state are the here now and where now. Our documentation page has some pretty good examples on here now and where now. Here now allows you to pass in the name of a channel and retrieve a list of the UUIDs or users on that channel. It also has the ability to retrieve global presence data. If you want to know who's on all channels associated with your instance of PubNub, you can pass, I believe, a nil channel, and that will return all UUIDs on all channels. Where now will allow you to do the flip side. If I know that I have a friend that's logged in, I could use where now, pass in that friend's UUID, and the SDK will then go out and tell me which channels that particular individual is on. Okay. Okay, making the world persistent with storage and playback. So we're moving right along. We've got a lot to go through, so I apologize if I'm moving too quickly. Making the world persistent with storage and playback. So we call this history in the PubNub land, but essentially what it allows you to do is retrieve a list of the messages that were published in the past. In order for this to work, you have to have the storage and playback option enabled from the customer portal. But once you enable that and then configure the duration of time you would like to store messages on the PubNub infrastructure, you're in good shape and you can use history from your solution. History is very, very useful, especially in a chat application where somebody might be on a chat room and send messages, kill the app, walk away for 4 hours, and then come back. If you want to show your user all those messages that were published since the time that they killed your app, then you're going to have to pull them from somewhere, and you're going to do that with history. So what you would do at that point is create a time token and ask for all the messages on a particular channel, passing in that time token as a start attribute. So here on the screen we have history, provides a means to retrieve messages that have been published in the past. And in my case, I'm doing it when I reconnect. I'm creating a time token. We'll get to that in just a minute. And then I'm using an instance of the client, which is passed in here, to retrieve history for a particular channel. And as usual with non-stream events, you have your completion block that you can implement to process the results for that. The payload for history, it's typically an array. The SDK does a good job at packaging all of this up for you. It gives you 3 elements: a list of the messages that were retrieved from history, the oldest message time token, and the newest time token. Why this is relevant is if you're retrieving history from a channel, the max you can retrieve at one time is going to be 100 messages. If you need to retrieve more than 100 messages at a time, then you're going to have to use the oldest time token that comes back with history to go back further in time until you retrieve all the messages that you want to retrieve. Okay. Limits the number of messages being retrieved. So if you just want to get the last 10 messages, you can do that. Okay. And as well, the history methods also all accept a start and end parameter that allows you to filter out the messages that you want to retrieve. And so in this particular case, we have, we're going to create a time token, or you can create time tokens here. So we have a start time token. We're just creating a time token, which will become the time token that you see here at the bottom. And I can then use that for either my start or my end parameter. Start always returns, if you supply arguments or values for the method, start always returns messages older than the provided token, not that particular time token, but any message older than the provided token. End always returns messages newer than the provided time token. And then start and end together, obviously, it will allow you to isolate a range of messages that you want to retrieve from history. Hold on a second there. Got some kind of a mouse issue here too. Include time token will return the time token associated with each one of the messages. So that does change the structure of the results somewhat. If you want to include the time token, that's the last argument that you can include on the history call, and it will just give you the time token associated with the messages being returned. If that's set to false, the time token will not be included. So if the time token is irrelevant to you and you just want to see what data has been published, you don't have to pull that time token down. It might save you a little bit of bandwidth. If you do need the time token, specify true there. Okay. All right, so we've went through quite a bit and making good time. So just a recap here, we set up your CocoaPod-based Xcode project by creating a project, a pod file, running install on pod, opening up the generated workspace. We initialized PubNub by instantiating an instance of PN configuration, associating that with the instance of PubNub, and then adding a listener. Okay, you want to add a listener. That's not technically a part of the initialization, but ensure that you add a listener. After we had that configured and we had an implementation of our PNObjectEventListener, we associated that with the PubNub. We subscribed to a channel using subscribe to channels, passing in an array and determining, telling the SDK whether or not we want to receive presence events. Once we did that, we were in good shape to receive messages. Publishing messages to a channel, we use the publish method, passed in our JSON-based payload. You can also publish strings, but JSON is the acceptable or the most typical data that we publish, or that you'll end up dealing with. And we publish that to a particular channel, giving the name of the channel, and publish is async. It accepted a completion block that should be implemented in order to determine whether or not that publish was successful or failed. You can also retrieve the time token within the publish method, or publish block, callback block, sorry. Listening for presence and state change events. Very first thing you're going to want to make sure of is when you call subscribe, you say that you do want to listen to presence events. That's the second argument, which is with presence. And then you want to implement your didReceive presence event PNObjectEventListener selector, and that will be passed in one of 4 events: a join, a leave, timeout, or a state change. And then we learned that as we publish events, they can be stored in storage, which is configurable, and you can retrieve that storage by using the history and any number of the arguments to determine which part or which time frame in history you want to pull messages down from. And just alone, those top bullet points, you could write a pretty robust application. If you're dealing with iOS and you're wanting to ensure that when users are offline, they also receive notifications that somebody has sent a message, then you're probably going to venture into the push notification realm, and that gets into PubNub's mobile gateway for push notifications, and that's what we're going to look at next. So push notifications. So PubNub is a gateway to sending push notifications, and I made that italic and bold. We don't actually send the push notification to the device. We are a gateway to the various service providers that do send that push notification. Okay, and there's many steps that you have to go through in order to set up push notifications on an iOS app with or without PubNub. If you were simply to do push notifications without PubNub, you'd still need to register for remote notifications. You'd have to have the proper application provisioning profile, the proper certificate associated with that profile, and so on and so forth. Okay, so just a bullet point, you need to have push notifications in order to use our mobile gateway. Back on the customer portal, there's an option there for using the mobile push notifications. You want to select that. You need to provision your application for push notifications. This is an Xcode specific thing or a developer.apple.com, but when you create a provisioning profile, you associate some tokens with that provisioning profile, and then you associate some capabilities with that provisioning profile. One of those is push notifications. You have to enable push notifications for your application. Otherwise, you're not going to receive push notifications. Okay. You need to generate a certificate and associate that certificate with your app provisioning profile. Once you have that certificate, you'll want to install that certificate in your PubNub customer portal or customer dashboard where you enabled push notifications to begin with. That's just a small laundry list of the things that you need to do in order to do push. And really the only requirement PubNub's putting on you here is that you enable push notifications, and once you have your certificate, you install that in the customer dashboard. Okay. All right. Again, we don't send the push notifications, but we provide a non-intrusive, fairly transparent way for you to integrate this capability into your PubNub solutions. And what I mean by that is when you publish a message to a channel, there's an option for you to publish a push notification to that channel as well. Depending on what SDK you're coming from, it's either by embedding the payload, embedding the push payload in your payload that you're publishing, or in iOS specifically, you have the option to pass a mobile push payload into the publish method, and we're going to look at that. All right. And so again, if I had a CB global channel and I was publishing PubSub messages over that, and then a user left the application, I could still notify that user that activity is occurring on that channel by sending them a push notification. And I would still use the same publish method that I've used before to publish regular messages. Okay. Small diagram, block diagram, your app publishes messages to PubNub. If that message contains the proper payload and your account's configured properly, we then forward that message on to the proper service provider. Small flow. Application enables remote notifications. This is for receiving a push notification. Application retrieves a device token. This is still on the iOS side. Application enables push notifications by associating a device token with one or more channels. That's PubNub specific. And then when the application publishes to a push-enabled channel and it contains the proper payload, the push notification will be sent to, in our case, APNS, and then sent back to, or sent on to the device. Okay. All right. Publishing a push, the channel must have one or more devices associated. Push notifications are very, very complex to diagnose sometimes because we are that mobile gateway and we're forwarding over to APNS, and there's very limited visibility once it leaves our side over to the APNS side. And oftentimes what I've found is that push notifications don't go out because there are no devices associated with the channel. Okay, and there's an enable method that you use to associate a device with a channel. If your channel doesn't have devices associated with it, there will be no push sent. Okay, the JSON payload being published must contain the proper push notification attributes. Okay, and we'll get to that in just a second. There's a sample payload coming up here. That one's, sorry about the blurriness on this one. Enable push notifications on one or more channels. There's one method, add push notifications on channel. In this particular case, we're enabling push notifications on a channel called APNS, and then we're passing in the push token. This is the device token that you would retrieve in your app delegate when you register or enable push notifications. And then, as with everything else, we have a small completion block that passes back a status, and you can check to make sure that there was no error there. So in order for you to associate a device with a channel, you need to have the add push notifications on channels called once you've received a device token, which is usually done in your did finish launching and then your did receive device token, the combination of those two methods. Once you have a device associated with a channel and everything else is in line, then you can simply send an APNS message. In this particular case, we're calling the same method, publish. We're passing a nil for the payload. You don't have to. You can send both a PubSub message and a payload and a push at the same time. But in this particular case, we're not doing that. We're just sending a push. We're specifying the channel that we want to send that message to, and then we're giving it our payload. So here's our mobile push payload. There's an attribute there called APNS, and there's an alert message. Okay, very, very important that it contains this payload. If this were from iOS, you could also be publishing GCM and MPNS, but you would need to make sure that your payload is present for those other two vendors as well. Okay, and then you have a completion block, check for your error status, and continue. APNS. I'm iterating on this quite a bit because it's very, very important. You need to have the proper payload, and the proper payload is documented on the Apple developer site, but I went ahead and I pulled one of their examples here, and here's a proper APNS payload. It contains an alert with a few attributes, a badge number, and then some additional data. Okay. At minimum, you need to have the APNS. All the other attributes are documented on the developer, Apple's developer site. PubNub doesn't really do anything specific with the APNS payload. We simply look for the presence of that APNS payload, and then if it's there and you're configured correctly, we forward it on. We do have some diagnostic capability on the push notification side. If you have a channel that has push enabled, you can then subscribe to a channel called test, or channel name -PNDebug. So if I had a channel called test that had devices associated with it, and I wanted to see what was happening with my APNS push notification, I could subscribe to test-PNDebug either using the developer console or a small app, whichever you want to do. And that will give me some indication that, number one, there are devices associated with the channel, that it recognizes that there's a push notification in a payload, and whether or not that push notification has been published. Okay. All right, so keep in mind, PNDebug is there, and you can subscribe to that. Okay. Oh. So enabling remote notifications. So this goes into receiving, we're moving from sending a push notification into receiving a push notification. Enabling remote notifications, that is typically done in your did finish launching it with options. And here we have some code to enable remote notifications. None of this is PubNub specific. This is all iOS specific. So if you want to register for remote notifications, the code that you need to implement is here. And it's pretty well documented, and we do have a sample, as I mentioned at the beginning of the webinar, that has this code in it, so you can go through and cut and copy and paste that code and make the necessary changes that you need to make. But in this particular case, we're just enabling remote notifications. Okay. And what will happen there is, as a result of implementing or enabling the remote notifications, your did register remote notifications with device token app delegate method will be invoked, and that will be passed in a device token. So if you remember a few slides back where we were associating a device token with a channel, and I think it was actually called push token on that slide, this is the token that you need. It is dynamic. You shouldn't store it in persistent memory, and it will be called each time you run the application. Okay, and actually this is a mistake. So fired once when the app runs. Okay, if it failed for some reason, if registration failed, then you'll get your did fail to register for remote notifications with error. So between these two methods, you need to get a device token. Implement both and at least log out that they've been called, so that when you're not getting a push notification and you're taking that journey to diagnose why you're not getting that push notification, you have some ideas to what's happening with the flow of execution in your application. And if you're calling into support or sending a ticket into us, it makes it a lot easier if we know, did these two methods fire off, okay, or one of the two. Once you have a device token and you've associated that device token with a channel and you've published a payload out to that channel that contains the correct APS payload, the next thing that you're going to have is a didReceive remote notifications method. Again, this is iOS specific. So what happened is we published the message to PubNub. PubNub saw that there was a push notification payload in that message that was published, looked at your channel, saw that there were devices associated with that channel, and said, okay, I need to send this over to APNS, which is Apple Push Notification Service. And then Apple Push Notification Service sends the push to your device. Okay, and there are constraints and documentation on how APNS delivers that on the Apple developer site, but at minimum, you're going to want to implement the didReceive remote notification, and that's passed in a dictionary. As you can see here, we're just grabbing some of that data out of the remote notification and then continuing on. If this were a production style app, you would probably receive this remote notification. It would probably contain either a time token or enough information for you to go back in the history or open a particular room and grab the messages that you need to show to the user, and then life can continue on. All right. So when the app is in the foreground and you're subscribed, this is a point of confusion. It was for me for a long time too. When you're in the foreground and you're subscribed to the same channel, you send a push notification to. So you're going to get both the pub sub and the push. Okay, so keep that in mind. Pub sub and push are two different things. When you publish a message that contains a push notification, it's going to be forwarded on to APS. If that push notification is in a payload that contains other data, it will be sent through your PubSub channel. Okay, so just be aware that you will receive both notifications, and you want to suppress one or the other depending on what your use case is. All right. Using Swift. So we've gone through a whole bunch, and I'm just going to jump right into using Swift. That was most of the core of publishing, subscribing, and sending push notifications using history and presence. Just given that those bullet points, you have enough to build a pretty robust application. Okay. Many of you are using Swift as it seems to be the direction that Apple's moving. So our Objective-C SDK can be used from Swift much the same way as setting up a Objective-C project, and that's what we're going to cover now. So we support Swift. The process is very much the same. As I said, it's the same process that you're going to want to use to set up a normal Objective-C project, with the exception of you need to add a bridging header. And that's what we'll do here. And there is a tutorial on how to set this up at the link below, which was also sent in the email earlier. So, all right. So again, you're just going to want to make sure you have CocoaPods installed. Once you have CocoaPods installed, create your project. When you have your project, when you're going through creating your project, instead of selecting Objective-C, select Swift. I believe most people have already done that. Create your pod file as we did before. Run your pod install. It's going to generate your workspace. Oops, there's Greg. How about that? It'll generate your workspace for you. I apologize. I have a very, very touchy mouse over here that just wants to fly through slides. Once you have your pod file created, you've run your pod install, and you've opened up the generated workspace, as we've indicated before, you've got your Swift project. The next thing you're going to want to do, and this is kind of a sneaky trick, but it works great, is you're going to want to create an Objective-C file. So in your Swift project, you would do a file new, create an Objective-C file. And when you do that, Xcode is, and it doesn't matter what you call the file, you can call it temporary, you can call it bridge header, whatever you want. It's going to create, or it will prompt you at that point and tell you that you're creating a mixed project that contains Swift and Objective-C, and will ask you if you want to create a bridging header. And what that does is it sets the linker options and the include paths up properly to include what we call a bridging header. Okay, so you're going to want to say yes to that option. And in my case, the result of me doing that, of me creating a new Objective-C file called bridgeheader.m, is what you see here on the screen. So it created the bridge header when it prompted me and asked me if I wanted to create configure a bridge header. I said yes, and Xcode generated this header file, the slides_swift plus bridging header .h, and it configured that for me so that the project knew where to look for imports from that header file. Okay, so we have our header. You'd want to open up that header file and just simply add your PubNub header file or your import of the PubNub framework there. Once you do that, you can write code in Swift and use all the same methods, the PNObjectEventListener, the presence, history, whatever the case may be, all work the same in Swift as they do in Objective-C. Okay. And here we have just a very, very simple Swift example, but it's not, it's just showing you that PNObjectEventListener is there, and then you can implement your Swift code. The link that was sent out has a tutorial and some additional code on that, and I'm sure there's going to be some samples here soon with the Swift. Okay, all right, so we've made it through all the slides. I apologize about the audio issues and the mouse. A couple things going a little bit rough this morning, I guess. There are some resources out there for you. At the knowledge base, we have a question and answer or form that you can post questions to, and somebody in support, myself or Craig or others, will be able to respond to those questions. We have a developer community that you can visit and post questions to. I'm sorry, the knowledge base is where you can read articles that have already been created that answer some of the more common questions. The community allows you to post and read and respond to questions. We have a support forum or email. If you have questions that you couldn't get answered this morning on the webinar, please do feel free to send a ticket in to support@pubnub.com or use the support form to send a ticket in, and that'll be assigned, and we'll address it as soon as we can. We're usually pretty good about getting back to people rapidly. And then obviously we have docs, demos, and SDKs at pubnub.com/developers. Okay. Upcoming events, we have hands-on with PubNub JavaScript SDK, very similar to this webinar, a little bit shorter. And then on the 25th, we have a Q&A with PubNub support. So that's where you can just come in and ask whatever question you want to us support guys, and we try to give you an answer. On August 26th, we have PubNub's Android SDK. So it's, again, another webinar that takes you through the Android or Java SDK. And then September 9th, we have building a secure chat app with PubNub, which is going to be very similar to what we have now, except using what we call Access Manager to lock down access to channels. Okay, and please do see pubnub.com/events for events.